Now we're going to look at our first example for the mean value theorem for intervals. It says find the average value, now again that means the y value, average y or f of x value, of sine of x on the interval 0 to pi. So if you recall, sine is wavy, okay? And we're just trying to figure out what its average value is from 0 to pi. Okay, so more or less it's going to look something like this. And we want to figure out what that average y value is on that particular interval. So average height of this graph is another way to ask the question. Step 1 is going to be just to label your interval a to b. So my a value is going to be 0. My b value is going to be pi. Okay, so that's very simple, right? Just figuring out what a and b is, what your interval is. Step 2 is to plug in f of x, a and b, into the average value formula. So recall from previous video where I explained this formula. Here's our formula for average value, 1 over b minus a times the interval from a to b of f of x dx. It's very simple, and after you do it a few times, it's very easy to remember. So notice I'm plugging in pi for b, 0 for a, and then plugging those same a and b values into the limits of my integral. And after I plug in my limits, then I'm just going to plug in sine of x in for f of x, because that's what my function is. So very simple. And then basically all you have to do is find the integral and then figure this stuff out, right? This is going to be 1 over pi. Step 3 is to determine the definite integral. So that should say pi. Sometimes when this converts to a PDF, it doesn't convert correctly. So this is going to be 1 over pi times the integral of sine of x from 0 to pi. Now the integral of sine of x is negative cosine because the derivative is positive, right? So if you go in the reverse directions and you integrate this, it's negative cosine. So we want to integrate, we want to evaluate negative cosine of x from pi to 0. So it's going to be 1 over pi times negative cosine of pi, so we're plugging in that in for x, minus negative cosine of 0. Now why is it minus negative? Because when you plug this in, you subtract the lower limit, and it's negative here. So it's going to be double negative, which we know is going to become a positive. Okay, so cosine of pi is negative 1, but we have a negative in front of it, so it's going to give us positive 1. Same for here. Cosine of 0 is 1 with a negative there. Double negative is going to make positive. So we're going to end with 1 plus 1, which we know is what? 2, right? So we get 1 over pi times 1 plus 1, and 1 plus 1 is 2. So you get 1 over pi times 2, which is 2 over pi. And again, I apologize for it not converting correctly. Final answer looks like 2 over pi, which is going to give us our average value of sine of x from 0 to pi. And I want to show you what that looks like so that the answer makes sense to you. Alright, so here's what this looks like visually. If I do 2 over pi, I get approximately 0.637 in my calculator. So the average value of sine of x from 0 to pi is equal to approximately 0.637. So all of these y values, again, if I just created infinitely many points on this curve from 0 to pi, the average of all those y values would be approximately 0.637. And the average of all of these y values of these dots would be approximately 0.637 of y equals sine of x from the interval 0 to pi. That's it. That's all the steps you have to do. It's very simple. Just plug them into the formula and evaluate. So if you have any other questions about the average value of this function on this interval, let me know.